Hello, good evening, all of you. Today we are going to discuss about the patch database creation in image processing. What is a patch? So I'm going to concentrate on a small section of an image, a group of pixels. Instead of taking the entire pixel into account, we are going to consider a group of pixels, a small 3 by 3 patch or 5 by 5 patch, so that we can train the CNN over the entire image and also with the patches, and then integrate the learning. So such type of research is in progress in nowadays, particularly in journals like the Visual Computer, where you can see two different CNNs trained with the entire image and also with the patches of images. So that is what, in that context, we are going to see how to create a patch database creation. That is, you have an image, whether it is for classification or segmentation. Right now, many works are going in classification of images using the full image and also the patches of images. So that's what we are going to see today. So to begin with, and to have the interest on the topic of discussion, let me elaborate on what is some of the work done in this patch-based image classification. So we can see the paper, that is a fundus image-based cataract classification. In this paper, they have classified cataract and normal images based on the entire image and the patch images. So when you look at the abstract, I'm not going to explain the entire paper, only whatever concept is required to know why we are going for patch extraction. That's what I'm going to tell now. So when you look at this, the proposed CRNN uses, that is CRNN, that is the convolutional and recurrent neural networks. So they are using both convolutional neural network and recurrent neural network. Why? For taking the advantages of both convolutional neural network and also recurrent neural network. So the convolutional neural network, what they are doing here is, with the convolutional neural network, they are taking the image patches. The image patches are taken as the input, and the weights are learned with the patches with respect to particular patches. And after that, what will be done is the recurrent neural networks. The recurrent neural networks is the LSTM, long short-term memory, that is being used here. So what the long short-term memory unit does is, it integrates the learning of local textures and also global textures. That is what is the LSTM. So in recurrent neural networks, LSTM is there. So the type of recurrent neural network used here is the LSTM, and also convolutional neural network. The regular convolutional neural network is also used. So what type of convolutional neural networks used are the conventional AlexNet, ResNet, and GoogleNet are being used. So let me read it out and explain. The proposed CRNN fuses the advantages of convolutional neural and recurrent neural networks to preserve the long and short-term spatial correlation between the patches. That is, if you want to look at an image, you may look at an entire image. Looking at the entire image, we have some information. Looking at small minute areas of the image, we have some information. That's what we now want to train the CNN with the patches of images and also with the entire images. Okay, so that has to be integrated after learning patchwise. The learning that has been acquired patchwise, the learning that has been done patchwise has to be ported to the learning connected to the full image also. That is what is being done in most of the research works published in the journal called Visual Computer. Okay, the name itself shows the scope of the journal. Visual computer in the sense how the computer is able to see the images in different resolutions. That is what is the point of discussion. So looking at the block diagram, so this is a fundus image, maybe a cataract image for classification. The cataract image for classification is not learnt as full. What is done is different patches are created. Patches of several sizes are being created. Of course, here it is of same size only, and those patches are used to train the CNN. So some feature extraction is being done here. I'm not going to talk about feature extraction because that is not the point of interest here. And all those features are being fused, and then they are subjected to LSTM, that is long short-term memory. So image-wise LSTM is also there, patch-wise learning is also integrated. So that is what is the concept we are looking at it. So this is nothing but the different CNNs, whatever we studied. The conventional CNNs like AlexNet, GoogleNet, and VGG. So all these CNNs we are using for learning the patches. So different CNNs are used to learn the patches, and then the learning that is done patch-wise is integrated with the full. So that is what is the LSTM or recurrent neural network that is shown here. Okay, an overview of the bidirectional LSTM. So I'm not going to explain about the LSTM. So what I can simply say is, here the integration of the patch-wise learning and the image-wise learning is being done. So first of all, to create a patch-wise database or to create a patch database. So that is a point of discussion. No. Suppose I am proposing another method that integrates the patch-wise learning and the full image learning. So I have to create my own patch-wise database first of all. Okay. So people have done patch-wise learning and full image-wise learning for the cataract classification and all. So particularly I am working with diabetic retinopathy. So when I am working with diabetic retinopathy, and that too I want to segment the optical disc and cup. So this is the first time we are going for patch-wise learning for a segmentation task. So we are taking the optical disc and cup images. So when you are going for classification of images with respect to diseases, to classify a certain disease, the user may be interested to create patches around the anomalies. The anomalies in the sense, the regions where medical information is there. So for example, here there is some blood vessel leakage or there is some uh, abnormality in the optical disc. So those patches can be purposely created and that they can be used to train the CNN with a label. So anything here we are talking about is only with supervised learning. So with supervised learning, we create patches and we also say what that particular patch corresponds to. Suppose if I am segmenting this, this is for cataract classification, let me say. So when the patches are being created, each patch will be given a label. So that patch indicates whether it is corresponding to cataract or not. Another patch, whether it is corresponding to cataract or not. So the entire image may be a cataract image, but only a certain region of significance is going to reveal whether it is whether the particular image is cataract or not, whether the particular eye is having cataract or not. So which is the region that is going to be significant. So in those areas we have to select the patch. That is what is going to give the success for the creation of the patch database. Okay. Suppose I am creating the patches over the peripheral region, which does not have any diagnostic information, then that patch may not be useful, that much useful. It may be a redundant patch occupying a unwanted space in the database. So that's why we want to create a patch database. We want to create the patches from the anomaly regions which give information about the anomalies, both from the normal and abnormal images. Okay, this particular region is going to have anomaly. Similarly, how that particular region is there in a normal image, that also we have to generate the patch. So now, anyhow, my interest is to create patch database for segmentation. So let me see. So this is one of the images taken from Drishti database. So in Drishti database, several images are there. The optical disc segmentation we are going to take into account. So when we want to segment an optical disc and also optical cup, so this is the actual fundus image, and this is what is the label. Label in the sense, in that particular image, this particular region corresponds to optical disc, and that ground truth is already given. So which is the region corresponding to the optical disc, and the background is simply shown as black. That means out of the entire image, this is the disc region, and this is the background, the entire background region that is also shown. So what generally in a CNN-based semantic segmentation work is taking into account is nothing but, so it will learn pixel by pixel. I give this as the input image and I give this as the label in the sense each pixel is learned with respect to this particular label. So for hundreds of images, the optical disc and background is being learned, and then when a new image is being given, it is able to classify it as a when it is able to segment the optical disc and background properly. So that is what is a supervised learning. Why we call it as a supervised learning? We are giving the label also. So that is very preliminary and everyone is aware about that. And now coming to patch database creation in that. So when we want to create a patch database for a segmentation task, so there is no use of creating patches from here or here. So what we want to do is we want to create the patches from these regions. So this is a region where we have to see whether it corresponds to optical disc or background. So this is another point where we have to see whether it corresponds to the optical disc or the background. So these are the regions we have to carefully choose. Again, apart from optical disc, we have optical cup also. So there is another database, there is another set of labels for optical cup. So this is optical cup. The central brightest region is the optical cup and the remaining region is the optical disc and then the background. Okay. So optical cup database is also there. We need to work on both optical disc and optical cup segmentation. So in such a case, first let me concentrate only on the entire image and optical disc segmentation. In such a case, if we want to find out the exact location, so you want to create a patch. I want to create a patch around this particular point. So what we want to do, I want to know the spatial coordinate. So what I will go for the size of the patch, whether 3 by 3 patch or 5 by 5 patch, what I have to choose. In all those terms, I have to think to create a patch database. I personally have done some experimentation and found that 3 by 3 patches and 5 by 5 patches have no significant information. So what size of patch we are going to choose is so it's almost 24 by 24 patch we are going to choose.